Hello, everyone. And wow, looks like we had over 400 registered for this webinar, so we'll see who shows up. But depending on where you're at, it's good morning or good afternoon. Welcome to our presentation, Pump Lift Stations 101. We're excited to share with you valuable insights on pump lift stations and sometimes the mysterious component in water infrastructure. We're going to start with an introduction to the presenters. I'm Chris Eberly, Vice President of Product Development for ParkUSA, and I'll be hosting along with my co-host, Will and Manish. Will, why don't you introduce yourself?
Good morning, everyone. I'm Will Doran, our lift station department manager. I help oversee lift station designs, in addition to supporting our lift station department with sales and project management.
Hello,
Manish?
everyone. Welcome to our presentation. This is Manish Nawal, Director of Engineering at ParkUSA. I oversee the engineering department at ParkUSA. For lift station side of business, I work closely with specifying engineers during project design phase and help with lift station design, pump selections, CAD submittal drawings, and project specifications. Today, I'll be moderating QA session at the end of the presentation and available online during the presentation to help with answering any questions.
So look, let's get started. ParkUSA is all about water infrastructure solutions. For 40 years, ParkUSA has led the industry with innovative and engineered water management solutions for water infrastructure. Water infrastructure, as everyone knows, I think everyone, water distribution, wastewater, and stormwater. ParkUSA has become a trusted partner for many building professionals who prioritize sustainable water infrastructure. In 2021, Northwest Pipe Company acquired ParkUSA, providing us with a much larger footprint to better serve the national industry. As you can see from this map, our expanded product lines include lift stations reflecting our commitment to quality, sustainability, and customer service. Here's what we'll be covering today in our session. Again, it's Lift Stations 101. We're going to start with an overview of what a pump lift station is, its importance and role in water, wastewater management. Also, we're going to cover some stormwater as well. Next, we'll discuss the various applications and practical uses of pump lift stations in different settings and different industries. We'll dive into the specifics of and key components of the lift stations, including the different types of pumps, valves, and control systems. We'll go over a sanitary detention pond, a sanitary design for a housing community, but we'll also touch on a detention pond pump design as well. We'll present the overview in a case study format showcasing both wastewater and stormwater. Finally, we'll open the floor to your questions, providing an opportunity to address specific concerns you may have or curiosities. We're confident that by the end of this presentation, you'll have a general understanding of a pump lift station and the fundamental concepts and practical designs. So let's get started, and we are going to watch a pump trooper video.
Water always finds its way to the lowest point in an area. This pull of gravity can easily lead to flooding, which can create health and safety hazards as well as property damage. Lift stations make it possible for commercial, residential, and community developments to defy gravity, collecting stormwater and wastewater in low-lying areas and conveying it to the municipal collection system at higher elevations. The Pump Trooper by ParkUSA, a Northwest Pipe Company, is a submersible pump lift station that offers a reliable and cost-effective solution for fluid conveyance and flooding control. With a variety of custom configurations available, we design our lift stations to the exact specifications and capacity requirements of your project. The most commonly used design is the duplex system. consisting of 2 pumps alternating in operation. Multiple pump installations like this provide continued service in the case of pump failure or maintenance and extra capacity in times of extraordinary loading. The Pump Trooper lift station works by collecting sanitary wastewater or stormwater into a wet well through an inlet pipe. As the well fills, an electric liquid level control system monitors the water level. When the water reaches a predetermined level, the pump engages, transferring the water up and out of the wet well basin into the sanitary or stormwater system. For high pressure or higher head applications, a grinder pump is recommended. The powerful grinder pump features sharp cutters that shred solids and move them under high pressure through smaller diameter pipe. The Pump Trooper is powered by a close-coupled electric motor, which operates quietly and is cooled by the moving liquid for a maximized service life. Made in the USA, our lift stations are pre-assembled in a controlled manufacturing environment, ensuring the highest quality product is delivered to your job site, ready for connection. Our team works directly with the field contractor to ensure proper placement and installation. Designed for the unique demands of commercial, industrial, medical, and residential environments, the Pump Trooper meets all building codes and comes with a variety of application-specific pump styles. The valve assembly can be housed in the wet well basin for smaller stations or in a pre-assembled valve vault for larger stations. Pump Troopers are available in precast concrete or fiberglass construction in a variety of sizes and with a selection of interior liners and an optional remote maintenance alarm. From corporate business parks to residential complexes, contractors, engineers, plumbers, and building managers rely on the trusted performance of ParkUSA Pump Trooper lift stations to keep their stormwater and wastewater moving onward and upward. Contact us to learn more about our water and wastewater solutions or visit us online at parkusa.com and nwpipe.com.
Hello, everyone. Thank you again for joining us today. I am William Doran, our lift station department manager. So today I'm going to be going over some various applications and components of pump lift stations. So what exactly is a lift station? Lift stations are used for stormwater or wastewater infrastructure to lift water from a lower or high to a higher elevation when natural flow is not available due to topographical constraints. Why would a pump lift station be considered when gravity is not possible or when you're required to pump long distances over a pressure? When the cost savings in excavation could be minimized. Note that some cities require a justification of lift stations comparing the cost of a gravity sewer line to the overall 30-year operational cost of installing a lift station. It can also be used to help reduce the risk of flooding. So lift stations are common in 2 main infrastructure areas, which would be stormwater and wastewater. In stormwater, lift stations can be used to prevent flood control, prevent flooding in low-lying areas by pumping stormwater to higher elevations. In urban drainage, they can manage stormwater in cities to prevent waterlogging of streets. And a popular application for stormwater lift stations is in detention and retention ponds, where water moves from these ponds to manage stormwater runoff. In the wastewater industry, lift stations can be used in the municipal sewer systems, where they will transfer waste from manholes to treatment facilities. In residential developments, they can handle sewage from homes and transfer them when gravity is not available. And in commercial and industrial properties, lift stations can ensure sanitary conditions and compliance with and health regulations. So how does a lift station exactly work? Influent water will flow by gravity pipes into a wet well, which will collect either stormwater or wastewater. When the water hits a predetermined level inside the wet well, a float, typically called a lead-on float, will activate the pump and lift the water from the wet well and travel upwards to a higher elevation. For lift stations that contain more than one pump, each additional pump would have a lag float, shown here in green. This float will turn on and allow both of the pumps to run at once if one pump could not keep up with the flow, or in the event of a pump failure. The lead and lag floats are terms used since typically the pumps will alternate starts for even usage on the pumps. Pump lift stations can get pretty complicated, starting with design and all of the various components required in a pump lift station. For specifiers, the pump trooper lift station can be custom designed to fit your needs and comply with your local codes. We can assist with your design, including getting CAD and Revit drawings and pump specifications. For contractors, we can make this process super easy and provide a single-sourced, pre-packaged lift station with all of the necessary components, piping, pumps, and materials required. The Pump Trooper pump lift stations can significantly enhance your project by offering systems that streamline design and installation. We have many prepackaged configurations available, which would include both precast concrete and fiberglass options, complete with pumps and controls, systems, piping, valves, fittings, and any accessories. At ParkUSA, we can manufacture precast concrete structures in between 3-foot and 12-foot inside diameters. We can also include HDPE liners based on project applications. These would typically be used in sanitary and corrosive industrial applications. We can also use various major brands of pumps in our pump lift stations, depending on your specifications or city requirements. Pictured here, you'll see a few of the various pumps that are utilized inside typical lift stations, depending on each application. In the following slides, we'll kind of dive into each pump type a little bit more in detail. So submersible pumps are pretty popular in lift stations for multiple reasons. They have efficient designs. They operate directly inside of the fluid, eliminating the need for priming and reduce friction losses. They're space saving. Again, they reside inside of the wet well compared to external pumps. They are reliable, where you don't have any outside factors on them since they're contained inside of your wet well. They can also be used for stormwater or wastewater applications, so they provide some versatility, and they're cost effective. Here you'll see a few graphics of some various lift station packages that we can include with or without valve vaults, depending on applications here. So the effluent pump systems are typically used for smaller flows to moderate flows. They're designed to for clear effluent and pumping treated wastewater from septic tanks or small treatment facilities. They're typically used with a piggyback float attached to the pump, or they can also have automatic float systems. We can design these types of packages in cylindrical or square wet wells, and they can include a grate top or a hatchway for access to the pumps. Non-clog pumps are very popular in lift stations. Submersible non-clogs are ideal for handling raw sewage and stormwater. They feature a non-clog impeller. They also feature, most of them will have a recessed impeller, which allows the ability to handle high solids contents. Typically, these pumps will allow for solids to pass up to the size of the discharge on the pump. Here you can see some of the inner workings of a grinder and chopper pump that are typically used in wastewater and sanitary applications. Submersible grinder pumps would have a cutting mechanism to shred or grind solid materials into kind of a fine slurry, if you will. These are great for systems that need to pump over long distances or against a great head pressure. Chopper pumps would also be used in a wastewater application or industrial use. They're useful when your waste has a lot of high solids content that would need to be sliced up into smaller pieces before going into the wastewater systems. They're chopped up using a cutter blade on the impellers and a cutter bar across the intake. So I want to talk a little bit about macerators. A very common problem for sewers occurs at detention facilities where vandalism is pretty frequent. Inmates will stuff bed sheets, towels, pretty much anything that you can think of down toilets and drains to intentionally flood the facilities. If these items make their way into the sewer system, this grinder will take a hold of the material and shred it into smaller pieces, allowing it to continue on its way. These systems will generally run they're 24/7, so they're always running, preventing clogs from happening. Our pre-engineered packages would include the vault in either a channel or direct inline system, the grinder in a single or dual configuration, an access hatch, controls, valves, and piping. We would typically recommend a brand like Vogelsing or Muffin Monster, but we can use any brand that is specified. Vertical turbine pumps are often used in stormwater applications. Typically, whenever you require a lot of high head or high flow, submersible pumps can get expensive, and this is another option. Typically, our package systems would include a additional jockey pump that is smaller to handle the lower flows or lower rains. These types of systems are easy because the motors sit above grade for easy access and maintenance. Next, we'll go over a couple of the different valves used in lift station systems. You have your check valves, which would prevent flow from coming back into the wet well. These can either be, ball checks or swing check valves. You also have isolation valves. These are needed for maintenance, flow control, efficiency, and they protect the equipment. These can be either gate valves, which are used for on and off control, typically with minimal restrictions. Plug valves are a little bit more geared towards throttling the pumps and offer an easy use. So our pump trooper systems are available with different valve assemblies. We can provide precast concrete valve vaults that are pre-assembled here at our office and hydrostatically tested. Each system's factory built and pre-assembled and delivered directly to the site. Sanitary lift station systems often use these for easy access to your valves for maintenance or if you ever had to replace one. They also eliminate any confined space entry into the wet well system. And since the valves are separated in their own valve vault, they don't have exposure to any H2S gas or corrosives that could be in the wet well. In this larger picture, you can also see we would typically provide a cam lock fitting on many of our valve vaults. These are used for easy bypass if for whatever reason your pumps went down or you had to pull your pumps. You can easily hook up and pump your lift station out directly into the force mains. You can also have above ground valve vault assemblies. These are generally going to be used, as you can see, with larger pipe sizes and valves. You can use them in both storm and sanitary applications though. The pump trooper control system offers an advanced and reliable management for your pump lift stations. Key systems would include pump automation, user-friendly interfaces, enhanced safety, and real-time monitoring, whether it be via a IoT, an auto dialer, or some sort of SCADA options. All of our panels would typically include a generator receptacle on the side so that you can easily connect some backup power. And the enclosures can be either stainless steel, fiberglass, and we can include any components you need depending on your applications. Just a few pump accessories. The Pump Trooper offers a range of high quality accessories designed to enhance your pump lift station for performance and efficiency. With the Pump Trooper, you will get a single source pre-packaged solution with your wet well piping, pumps controls, and any accessories you need for easy installation. I'm going to now turn our presentation back over to Mr. Chris Eberly, and he's going to walk through our case study and our designs with you.
Thanks, Will. Now let's talk about our case study. We'll walk through an example of how to design a pump station. In this example, this is going to be a housing community near Austin, Texas, that requires a wastewater lift station to transfer wastewater to the nearby sewer. Here's some project conditions that are worth noting. This residential community has 150 homes. The sanitary sewer needs to be extended about a quarter mile to a manhole where then it will gravity flow into the public sewer to the wastewater treatment plant. The inlet piping for this lift station is about 10 foot deep. One important condition is that there's only single phase voltage available at this site. in which, for the most part, anything over 3 horsepower is going to require 3-phase voltage. So we'll get into that here in just a minute. The engineer also wanted to ensure longevity of this wet well, so we included in this unit a high-density polyethylene liner that will provide that. As you can see here, this is our design request form that the specifier will fill out to get it started. In this particular project, the specifier contacted ParkUSA and provided us with the key details of the project, specifically his draft of his project plans, flow rates, head requirements for the system, which we then went to work to develop a complete lift station design. So here's a few steps that we recommend to follow for lift station design. You have the site selection, and that's going to be really dictated by the project site and a lot of different variables that go along with that. Estimating the flow rate, wet well design and sizing, establishing and calculating the total dynamic head, the pump selection, the controls, lift station accessories, and then plan drawings and specifications. So we'll go over the site design or the site selection. For one thing, we need to make sure you choose a site that's going to accommodate the pump station in relative to the local terrain, the elevation factors, and things like that. Accessibility to ensure that the site is accessible with by vehicles and personnel. You may have to pull up a service truck with a crane mounted maybe to pull the pumps at times. So we need to make sure we have access to the site. The environmental impact, we need to minimize the impact and that will comply with local regulations. And you definitely want to avoid flood-prone areas. And of course, the proximity to residents, situate the system to where it minimizes the noise and odors. If it has, you can add odor systems to this as well if that's going to be an issue. The next thing we're going to do is estimate the flow rate. For this subdivision of 150 homes, each having an average of 3 persons and using an ADF, which is the average daily flow of 100 gallons of water per person per day, and considering a peak factor of 3.5, the estimated peak flow rate is calculated to be about 110 gallons per minute. Let me point out a couple of those acronyms. The ADF is the average daily flow rate of each person, and this ranges typically between 70 and 100 gallons per day. The PFF, that's the peak flow factor, and that's a multiplier applied to the average daily flow to account for peak usage periods. Those typical ranges are 2.0 to 4.0 for residential. In this case, we're using 3.5. For commercial applications, that's going to be 1.5 to 2.5. Now, these values are often specified by the local municipality or state government, so be sure to research this information for your project. And this estimation of the flow rate is going to help us in designing the lift station as we go through this. Next, we're going to talk about the wet well sizing. Again, this subdivision is 150 homes, and the wet well is designed is going to be able to handle 110 gallons per minute. The calculated active volume required between the lead on and pumps off, and that's according to this graph, that's going to be between, this picture is going to be the dimensions between pumps off and lead on. We calculated it to be 275 gallons. This will ensure that the pump does not exceed the maximum cycle rate of 6 starts per hour. If you exceed the manufacturer's recommendations of starts per hour, you could prematurely reduce the life of the pump. So in this case here, the pumps that we're considering, we were using 6 starts per hour. We determined the wet well diameter to be 5 feet, and that was basically done. We anticipated a diameter basically from the size of the pumps that we're going to be using, and to provide plenty of room in there for the pumps and for the floats and the piping. So with this information, we can actually calculate the control elevations, the control floats. So this is going to provide for adequate motor cooling, prevent overflows and backups, and ensure a efficient system operation. So the next step, we're going to talk about the total dynamic head. Here in this calculation, the total dynamic head is going to be the sum of the static lift and the sum of our friction losses, which is going to be due to pipe and fitting losses. So as you can see here, we've estimated this to be about 37 feet of head. We'll use this in our next step. Next step, we get into pump selection. So on the pump selection, we got, I put a few important factors there. And, for one, it needs to handle the conditions that we calculated. So at 110 gallons per minute at 37 foot of head, the pump needs to be able to perform that. For redundancy, this is going to be a duplex system, which is going to offer 100% redundancy if one pump were to fail. Each pump is going to be sized at 110 gallons per minute at 37 feet ahead. The other thing this duplex will do is that if both pumps are performing, if the flow rate ever exceeds those conditions, the 110 gallons per minute, the next pump will step in to assist the primary pump. And it's a lead lag operation. The lead pump powers up, it starts to pump, and if the level in the wet well continues to rise, the lag pump will kick on. There's other considerations too. Their brand reputation, reliability, maintenance cost, compliance issues, technological features, and warranty. So these are all factors that you want to ensure that the brand of pump that you spec meets your job site conditions. And the next thing we're going to do is we're going to actually plug in our parameters within a program that actually will help select the exact pump to fit our conditions. Every manufacturer of pumps, every reputable manufacturer will have some type of computerized selection guide that will help us do this. And what your end result will be is a printout of the actual pump and the performance parameters. So as you can see here to the left, it's a data sheet that prints out all of our factors for us, all the results. And then on the right-hand side, you can see the resulting pump curves. And you can see where our mark is. There we're actually sitting on the curve in a nice area. So we're going to be able to select this particular pump going forward. Next, we get into the control system. And one of the factors that we want to do on a duplex system is the pump alternation. So as I mentioned before, these pumps will alternate lead to lag, and every time the cycle starts, a different pump will actually start up. And what this does is this helps even the wear of these pumps. So each pump will have the same amount of hours on it, so it evens the wear on these pumps. We determine where the level control floats are going to be. So as you can see here, the bottom float is going to be our low level pumps off float. And then as we rise up starting at the bottom of the wet well, the next pump float switch is going to be the lead pump on. The next one is going to be the lag pump on. And then our final float is going to be the high level alarm, which is going to be situated relatively near our inflow pipe of the lift station. Then we get further on the control system. Let me just go over a few unique things for this particular system. Again, this is a duplex lead ladder operation. It's in a weatherproof stainless steel panel. And remember what I said earlier about the voltage that was available at the job site, single phase. Well, it turned out that the pump that we've chosen is a 5 horsepower pump, which requires 3-phase power. So what we did was we included a VFD system, and that stands for variable frequency drive. And we're using that for phase conversion. So we're able to take single phase voltage, in this case, it's a 240 volt single phase, and we're able to convert that to 240 volt 3-phase. And there's other areas where VFDs can help a system, and that's enhance the energy efficiency performance, and really cause us to be very energy efficient. By the way, this actually is, I read the other day that this is actually helps reduce our carbon footprint, right? We use less electricity. So there's a lot of there's environmental benefits and cost savings by using a VFD system. In this system, we have on the level sensors, we're actually using those backup floats as the floats as actually backups. We're actually putting a pressure transducer in here where we're able to maintain exact and precise level inputs to our control panel. In this panel, we're also got elapsed time meters, which will tell us the usage of each one of these pumps. Generator receptacle for all of our units, control systems. We always put a generator receptacle at the panel. And what this does is if we have a situation where the lift station is without power for an extended period of time, it gives the operator the option of pulling up a generator and plugging in and basically keeping us online, even if it is through an extended power outage, and that would be a storm, hurricane, or any other type of weather condition. The clever system, the component of this system is actually that this system is using a Grumpus Connect system, which is an IoT system. It's basically using cellular platform to report and monitor on this system, and it really enhances the serviceability. We offer maintenance contracts for these type of systems where we can actually monitor this 24/7 and actually deploy our service group to attend a lift station that seems to need or seem to have issues. There's other accessories that are on this system. And as you can see, there's a couple of pictures as well. The guide rails, we use all stainless steel components for retrieving the pumps. Those systems are nice because you do not have to enter the wet well, which could be a confined space. So those are important. Access hatches, we're safety conscious. We put safety nets in all of our hatchways, and that's a nice feature. Gooseneck ventilation systems to ensure proper air circulation and to avoid hazardous gas buildup. Again, pump lifting, chains, and handles, it's all stainless steel components. Check valves to prevent backflow and maintain proper direction. Plug valves for easy operation. and maintenance. Alarm systems, as I mentioned earlier, and electrical control boxes within the unit that are all watertight. Now we're going to go to our final step, which is our deliverables here for the specifier, and that's plan drawings and specifications. As you can see here, this shows the site elevation view and also the plan view. Sequence of operation, pump schedule, and keynotes. And these are offered in a CAD format. So we're working together with the specifier to design the system. So we'll make these available to him. The next drawing is going to be our specifications for this system. So the specifications cover everything from installation to materials to serviceability to startup and everything you need there. On the right-hand side, you'll see the pump performance curves and the specifications. And then our final drawing is going to be the details for the control system. And on the control system, you'll see electrical load analysis and all the parts needed for the control system. And again, these are offered in an AutoCAD format, and also if there's any MEP engineers out there, we can also offer this in a Revit as well. So I'm gonna throw some bonus material out here. This is a stormwater lift station design. As far as there's a lot of shared characteristics of the stormwater and the wastewater. But on the pump sizing, it is a little bit different. That's what I'll go over here. So this is a stormwater lift station that's going to transfer water from a detention pond to a roadside ditch or a local storm sewer. So this detention pond actually has a volume of 300,000 cubic feet, which translates into 2.2 million gallons of water. In this particular county, the stormwater regulations require that the pump drainage, the pond drainage to drain within 24 to 48 hours. The specifier wanted to be conservative here and do it in 24 hours. So doing the calculations, we needed to use, it's going to require 1,558 gallons per minute per pump. Since this is set up to be a lead standby configuration, which means that each pump needs to be able to produce that in the event you have a pump failure. So what we end up with on this particular case is each vertical turbine the pump is actually going to handle 1,558 gallons per minute at 25 feet ahead. So what you can see in this picture, this is actually a wet well. It's going to have 2 vertical turbine pumps in there, and as you can see, the motors are sitting on top. And some advantages there are the motors are on top and outside of the water, so they're easy to service. And the reason why we do it on these type of pumps, because they're large pumps. These pumps could be anywhere from 25 to 50 horsepower, so it's a heavy pump motor. So it enhances the serviceability. So each one of those pumps is pumping out of that wet well and discharging into that square discharge basin. And then there's going to be I think on this job, it's a 24-inch or 30-inch RCP pipe that actually exits that discharge basin and goes into the local storm sewer. So that being said, oh, hey, and by the way, there's I remember I mentioned an emergency generator receptacle. On this case here, they have not permanently wired the power to this pump. So the contractor pulled in an emergency generator, trailer mounted, and actually hooked up, and he's actually running that system with the electric generator. So I'm going to invite Will to kind of jump in here with me on some of these pictures. As you can see here, these are some job site photographs. And what it looks like on that one picture there, it looks like, is that, Will, is that a 10-foot or no, it's a 12-foot diameter
There's 12 foot.
basin, 12 foot. And judging by the that inlet size, that looks like this is definitely going to be a stormwater wet well. So as you can see, they're offloading the first stage of that and setting it into a shored excavation by the contractor. And I would say this is part of our success in lift stations is the fact that we help with the logistics and the setting of many of these stations. So that's a tremendous advantage for the contractor.
I think on this one, it was a smaller sanitary lift station. You could see that ParkUSA has their own crane trucks, so we can help set the lift stations into your excavation for you.
So that system there, that looks like a this is an example of when we make a system, you'll see that a lot of these are going to be too big to transport all put together. So what we do at our plants is we design these, build these, and dry fit all the components in our plants. But then we have to take them apart to be able to ship them. So as you can see there, there's discharge piping with some plug valves on there. And then on the right, you can see some of the discharge vaults. And on this slide, here, as you can see, we're looking down one of the wet wells. This looks like a wastewater application. It's a 4-foot diameter, 12.5 foot deep unit. As you can see, our hatchways, we provide a safety net for all of our hatchways. Then on the right-hand lower right, you can see that's a discharge vault there, pre-piped and with Schedule 80 PVC pipe. And as Will mentioned earlier, in the center is that cam lock with a valve, which will enable, if they do have a clog downstream, or if they have issues with their pumps, they could actually connect on there and actually pump down and suck out the lift station. And now we're going to open up for questions. So Manish, do we have any questions out there?
Yeah, we have many questions. Some of them, like we already answered in the chat and in the presentation, but I'll read it again. The first one is like, do the pumps in a duplex system alternate between lead and lag?
Yeah, sure. Your pumps would alternate starts. So every time your lift station needs to turn on, pump 1 would run. And then, the next time it would turn on, pump 2 would run to get it even wear.
Okay. We'll go to the next question. And that is like a couple of people ask, do we provide sign and seal design calculation for structural components for our lift station? And yes, we do provide the sign and seal drawings and design, but we'll need the geotech report and the project conditions. Then we can design it and submit it for approval. Next question is like, what material is applied to the joints of our manhole sections for wet well? Will, you want to take it?
So for the joints, we typically apply a ram neck substance to keep the joints together and prevent leaking.
Next question.
Yeah, we also use use it for an HDPE liner, for example. We can use not only a ram neck seal, but we use a butyl rubber seal. When we use our on our HDPE liner, we actually have a rubber gasket, a perimeter gasket that is on each section, the male and the female joint. So we do have a positive and a proven connection to that.
Okay. The next questions we have, like Chris, you already explained it, but I'll ask again. The backup power supply. Do we have like emergency backup power supply?
Well, it's difficult to do that for, let's say, pumps, right? But we can definitely do that for control panels, because they can be operated, with a battery backup. For example, when we do an IoT type system, the control panel will be still in communication. However, the pumps may not be. Now, an engineer can design or specify a backup power system, which is going to be a generator.
Correct.
So, but yeah, those are options that are available, and we can help that in that design.
The next question is, where did we get, or what sets the criteria of pump cycle rate starts per hour?
That is going to be dictated by a lot of times the pump manufacturer will set those parameters. However, your local municipalities may do that as well. So they might just do a general start-stop cycles. However, every pump manufacturer they know the limitations of their pumps, so they'll actually state their maximum as well.
Correct. And when we design the lift station and select the pump, we make sure like we don't exceed the maximum starts per hour.
Yeah, we're pretty conservative on that number, and we don't get anywhere near the maximum cycle time.
Okay. And next question is like, what is considered the nice part of the pump curve and why it is important? For the pump curve, how do we select the pump that would work for that application?
I mean, there's some general rules on that. For example, on a stormwater system, you would hardly ever use a grinder pump, right? The pumps are designed for the application. So when there's a question on that, we can certainly work together and come up with a solution for what pump type to use.
Next question is, what is the best equation for total dynamic head if we have more than one drop in the force main?
So for if you have more than one drop, typically you would use your highest point in your force main to calculate your static head. And then depending on, how many drops you have, you would factor in, your 90s or 45s in your force main to calculate your TDH and friction loss. But you would always go off of your highest elevation in the force main for your static head.
Yeah, that's what we do, like for the highest elevation for static head, and for the friction loss, you use the force main and all the equipment in between. Next question is for like stormwater application. And for stormwater application, if the local jurisdiction require the outflow to be restricted to a pre-development condition, can the pump be designed to match the restricted flow? And another question with the same question, does ParkUSA design request form has a space to put it in that information? So for stormwater, if yes, like we can design the pump based on the restricted flow, and I think you can provide that information on the design request form on the notes section for stormwater.
Yeah, not only that,
Chris,
the design request form gives us some information, but when we're working with the specifier, this is all information that we can communicate with via email and phone calls.
Will, do you want to add anything else?
There's a question here about vertical turbine pumps being an option for kind of high flow, low head, and asking if that's a submersible pump can do it. So vertical turbines are used for higher flows. You know, once you start getting into 5,000, 8,000 gallons a minute, it's generally more cost effective compared to a submersible pump.
All right, guys, and remember, visit our website, parkusa.com. There's plenty of downloadable resources for you guys for your specifications, and our job is to help you specify your project. So let us know how we can help. We're available and look forward to talking to you guys.